I will. Okay, I think we're ready now. Again, I want to welcome everybody here. I appreciate you being here. I'm hoping you guys have had the last couple of days have been pretty good, and you've got to see some other stuff that we've got spread around. Maybe you got to see some of the other talks and everything. And our exhibit area has been actually fairly busy, so I'm glad you're here, seriously. My name is Brian Mitchell. I work at the Marshall Space Flight Center in Huntsville, Alabama. I've been with NASA for getting close to 33 years now, so I've worked on several different missions and programs in different offices over the years, and now I'm in the in PMPO, which is the Planetary Missions Program Office. And we don't do, well, I'll show you in a minute. What you're going to see in a minute are a few charts about our office. I'm going to tell you a little bit about what we do, who we are, the types of missions that we have, including the mission that brought us here this week. So let's get to it. All right, who we are. This chart, there's not a test on this chart, okay? I just wanted to give you some idea about the size of our office. It's not a huge office, but it's a pretty good size program office. You'll see most of we've got cost and integration, product integration, business management, mission managers. Some of the mission managers are here this week and helping out. Stephanie and I are up there under communication and outreach. We've got our own procurement people, S&MA. It's a full-up program office. So it's located at Marshall, and it's been there through several different iterations. We just keep adding on to it is what we do. What we do. All right, we're basically three parts. We're the discovery, the new frontiers, and the solar system exploration parts. They are separated basically by the complexity of the mission, the cost of the mission, and by complexity I mean necessarily how difficult it is to turn it around, how much time it takes for the planning and the build, and the length of the mission itself even. And so we divide them between discovery, new frontiers, and solar system exploration. I'm not going to read all that to you. But this is sort of a brief chart about several of the missions that we have in our office. Some of them are a little bit older missions. We're going to go through those as we talk. We're only going to talk about current missions. We've had several missions over the last several years that have completed their life, and we don't say crashed. Some of them have deorbited into various planetary bodies over the years. So I like this chart, and I've not seen this chart until just recently. This is our operating science fleet, and to be honest with you, I really didn't realize we had that many things. We, out of our office, don't focus on most of the Earth-based robotic missions, and we don't focus on that many of the solar-based robotic missions. We do some of the Martian missions. Many of those are done out of JPL, but we still do several of those. In fact, the last launch that we had here was a Martian mission. It was an InSight mission. I don't know how many people remember that or not. Great. And anyway, the rest of the ones you see on this chart are many of them are managed out of our office. We have program oversight over these missions. Many of these missions are built at universities or managed by other NASA centers, and we just have, yes, sir. Oh, okay. Great. I thought you were raising your hand. And that's another thing. If you want to raise your hand and you want to ask a question, that's perfectly fine, okay? So, first one we'll talk about is the Discovery program, and we'll start with InSight because, like I said, InSight flew from Vandenberg a couple of years ago. I heard it was a great flight. I got to hear it. We were sitting up on the side of the mountain, and I think that the marine fog was supposed to come in at about 600 feet, something like that, and we were at about 650 feet, and it came in about 800 feet. So it sounded great, but I didn't actually get to see it. but it was a beautiful launch if you were in an aircraft. So that's an actual photograph of that launch from Vandenberg. Yeah, I like that one. That was my screensaver for a while. Anyway, LRO. LRO is one of our oldest missions, current missions that we've got going right now out of our office. It's the Lunar Reconnaissance Orbiter. And it was actually one of the first missions that I worked on out of this office. It's, as you can see from the chart, one of the things that I think is pretty cool about that is that it's already collected more data than all of our other planetary missions together. And before LRO, some of the best data we had, some of the best mapping that we had of the lunar surface was Apollo. You know, we had still pictures from Apollo was probably some of the highest resolution videos or pictures that we had. Yes, sir. Absolutely, absolutely, and they're still sitting there too. So, yeah. But when we launched LRO, and LRO gave us, I'll put it this way, generally speaking, you can see your average size meeting table in a lot of the high-res areas that we've looked at. If you go online and look under the LRO websites, you'll see the rover tracks and trails and foot trails and everything else. You'll see landing sites. You'll see hardware still on the ground on the lunar surface, and all of that's from, I think that's from the LROC camera, is it not? LROC camera on that spacecraft. So where Apollo, we had to sort of guess a little bit, and we had a couple of issues, last-minute issues, trying to find a really good spot to set a lander down, and had to actually take over control of at least one of them because the planned landing spot was a little too rocky. We can plan these things so much easier now based on the information that we've got from LRO. Lucy is another one of our missions, and Lucy launched last month out of Cape Canaveral. It was a beautiful launch. I have videos of that. That's what I should have put on here. I should have put my launch video on here. That would have been kind of neat. But Lucy is going to study the Trojan asteroids. The Trojan asteroids are some of the most pristine asteroids that we have. I mean, they're captured in orbit. They're not in the asteroid belt where they're just banging together with everything else. So they've been captured, and they don't interact with each other like a lot of the other asteroids do. So we're hoping that by studying those, we get a much better idea of the makeup of these asteroids and how they came about, and how the early solar system was formed. MEGANE is another interesting program. That's Brad there, by the way. I could start talking about some of these people's names because they're like family to us, and like I said, several of them are here helping this week. But it's another discovery program. It's going to arrive at Mars. It's going to talk about or study Phobos and Deimos, Martian moons, where you know quite a bit more about Mars or the Martian surface than we do the moons around Mars. So we want to study those. We've got the P-Sampler, another Brad mission. And you need to look that one up. That's another interesting. What we're studying a lot of moons now. We're studying a lot of asteroids now. We do study other planetary bodies as well, but we're sort of refocused at one point to start looking more at asteroids and things like that, which is great because I mean it's a great place to find some of if you're going to find building blocks for life. These are some of the earliest, most primitive and pristine pieces of rock and metal in the solar system. Psyche is a really interesting one. Speaking of an interesting asteroid, this is going to visit an all-metal asteroid, and we have so many questions about this asteroid. It's we don't know. Some people suspect that it's the actual core of another planet that we don't know if it was obliterated by some large object that blew all of the crust away from it. There's a way to tell based on how this asteroid is decaying, like if it's decaying from the inside out or the outside in, as to potentially what happened to it. So that's what we're going to study there, and that's launching. When is it launching? August of next year. So several of these things are coming up, reasonably quick. Strofio, another. What's one of the things that I like about Strofio? It gives me an opportunity to talk about the fact that we actually partner quite a bit with other space agencies. We partner with ESA, the European Space Agency, JAXA, Japanese Space Agency, and that's important to us because, sometimes they've got a little extra margin on a launch and they can fit in an experiment of ours, and sometimes we have a little extra margin on a launch and we can fit in an experiment of theirs. So it's really teamwork, and in the science field, you see a lot more of that than I think you see in a lot of other places. You see a lot of teamwork between various countries. You put out, if whatever we find, whatever we discover, we shoot for like 6 months before we get the data out, and that data is available to anyone and everyone. And we are getting quite a bit of cooperation from other countries to do the same thing. Some of them may not hit that 6-month window, but eventually they get that information out and try to make it available to everybody in the science community. SIMPLEX, Kevin's got this one, and I know that looks a lot like the LRO spacecraft, but it's not. You'll see several different experiments on SIMPLEX. Another asteroid mission, basically. Small rubble asteroids. We've got the New Frontiers Program Office, which is a little bit bigger, generally bigger missions, more complex, expensive. This one is Juno. Have anybody heard of Juno? Okay, well, I know you have. Okay, Juno is currently orbiting Jupiter, and I say orbiting Jupiter. It's an interesting orbit, actually. It's not in any kind of sort of tight orbit around Jupiter because Jupiter is a kind of a bad place as far as radiation goes. So we put it in a very long, elongated orbit so that it passes by very quickly and spends as little time as possible in Jupiter's radiation. But I don't know if any of you have seen any of the videos or online or anything, but it's amazing what we're getting from this spacecraft. I don't remember exactly how many laps we've made around it yet, but it's several. And we study the cloud formations. There's instruments in there that help us study the core, or well, not the core, but the surface underneath all the clouds. But it's getting close to the end of its life. It's still got a few more miles left on it, but that's definitely one that's worth looking up. New Horizons was one of our favorites. New Horizons launched. Wow, it's past. What was that? 11 years ago now. Okay, something like that, because it took 9 years to get there. It took 9 when it launched. Pluto was a planet. When it got to Pluto, Pluto had been reassigned. I'm not going to say demoted, but reassigned. So it took a while for it to get there. And I remember when we first started talking about this thing, the best images we had of Pluto were just blobs, and it was almost kind of embarrassing So we've gone, well, you can look at that picture and see that we've come a long way. And we scooted past that thing. We weren't able to stop. We were going so fast that we weren't able to stop. We just flew past it. But since then, we've been able to redirect that spacecraft, and we're heading to other Kuiper Belt objects to study them as well, some of the other major Kuiper Belt objects, so that we can, the spacecraft's still performing well. There's no reason for us not to do that. We had a little extra margin in fuel, so we put together a team and came up with some other targets for it. So that's a really cool mission. Okay, you gotta love this one. Dragonfly is a planned mission. Joan's got that one, and it's a drone, and so Titan has enough atmosphere to support a drone, whereas we couldn't really do that on. It'd be much more difficult to do on Mars, something like that. But we can do this. We're really good with rovers, and rovers are great, but there are obstacles on the ground, obviously, with rovers, and they take a lot of time. Plus, you're driving these things, and you've got a delay in time between when you can send a command and it actually executes the command, and then it comes back and tells you what it did or didn't do. And so this will allow us to hop around on the surface and explore other areas that we haven't really been able to do before. So that's a very exciting mission. OSIRIS-REX, another great mission. OSIRIS-REX went to an asteroid called Bennu and took samples. And I remember when we had a big all-day thing about it arriving at Bennu and getting prepared to touch the surface of it. It didn't land on it; it just touched the surface of it. An arm extended with a collection tray on it. It touched the surface, and we blew gas at the surface, which blew a cloud of debris up, which we caught in a collection pan. The only worrisome part about it was when we closed the collection pan, we lost some of the sample, and so everybody's like, oh no, we did all this and we lost the sample. But come to find out that more than likely, we just had so much of a sample that when we closed it, we lost some of it. So we still have quite a bit left, and that returns, that was put into a capsule on the spacecraft, and that will return in, 2 more years? Yeah, in 2 more years, that's going to return, and it will land in a desert in the Midwest, and we'll get some samples from that asteroid. So that's the first time we've had samples that haven't been heated, superheated, exposed to oxygen, and all of that stuff. So we'll get pieces of asteroid that are just like we picked them up out there. So that's another pretty interesting mission. I think all of our missions are interesting. Solar system exploration. DART, why we're all here this week. You've probably heard DART and know it as well as we do by now. But anyway, just in case you don't, DART is a ballistic mission. It's the first of its kind. It's to support the Planetary Defense Office, which this is the first mission of theirs that we've had. It's a proof of concept mission. It's more than just more than one concept. We've got several different things flying on it that are kind of new to us, and so we're hoping to learn about. I mean, it's got electric propulsion on it. So that's kind of different. We don't use a lot of that. So that electric propulsion unit on there should get it up to about 15,000 miles an hour before it reaches that asteroid. So it's not a very, very, very big spacecraft. So we're not really relying on the mass of the spacecraft. We're relying on the speed of the spacecraft to do this thing. So we're going to hit that thing. Hopefully center of mass and just try to slow it up just a little bit. And if we can slow it up just a little bit, it should change the orbit of it. The orbit should be basically a little bit smaller, and we should be able to see that from here. So we want to know if we can do that. We want to know if we can affect these things if we have enough time. You know, can we look at these things and see if we can't budge them just a little bit, maybe this way or that way, if it's something that could potentially impact us. There's other technologies on there as well that we're working out. The solar arrays themselves are brand new. We've never deployed solar arrays like this before. If they roll out, you know, they don't just unfold like most of them have before. So it's taken less room in the spacecraft for these solar arrays, and we can put out larger solar arrays to gather more energy if this works. Excuse me, when this works. Europa Clipper and Europa Lander, that's another biggie right there. That's one of my favorite concepts is trying to find not just, I mean, what a great thing to find fossilized microbial life or something like that on Mars, but to be able to actually find something that was wiggling a little while ago would be pretty cool. And these ice giants, these ice moons, are probably some of our best bets to do that. We're looking at these things, and most of them, they're covered in ice, but some of them have warm water oceans underneath them, and they have a solid planet underneath the warm water ocean covered in ice. And anywhere you look on this planet, it doesn't matter how hot the ocean is or how cold the ocean is, there's life. You know, we can find life on any place where there's an ocean on this planet. So it's kind of exciting to be able to do that. And there's another one called Enceladus that I think will be another good bet for us, because at the poles, we know it has active tectonic plates in it, and what that means is that sometimes the ice cracks, and when the ice cracks, you see these geysers come out of this ocean water, and I would love to see a mission where we fly through these geysers and see what's in it, what's in that ocean water. You know, what can we detect in it? Yes, sir. Right. And that's what we're looking for. That's exactly what we're looking for. And so I think that's pretty exciting as well. And this is sort of the beginning of that. So, JUICE, another partnership with ESA. It's another mission to Jupiter. Again, there's nothing that we're doing that's, I think it may be boring to some people, I know, but when you look at what they're doing and what they're trying to accomplish and what they can learn from it and what we can learn from it, there are no missions that aren't interesting in this one. So another icy moon that we're looking at. The NEO Surveyor. This one I think is important, especially when you're talking about DART, because one of the questions that we get a lot is that, okay, what's the next step after DART? And there's there are a lot of concepts as to other things that we can do for planetary defense. But I personally think that one of the best things that we can do is have an array of technology to spot these things. We have a pretty good idea of the really, really large things out there, but there are a lot of potentially dangerous smaller ones that we don't know. We haven't been able to see yet. We can't detect them, and by the time we detect them, they're kind of close. And so having some things out there that we can actually see further, detect this motion, this movement coming near us, to us, whatever, I think is significant as being able to redirect one once we see it. Because the further out we see it, the more that we can do to mitigate the situation. So, And that, all on charts, we can talk about several other things if you want to. We can talk about, I do have some more charts on DART. If you really want to talk more about DART this week, we can do that. If you have any questions, love to answer questions. Anything you want to talk about right now. And I know you got a question. What's your question?
Well, you talked to us about that Dragonfly.
Right.
Mm-hmm. That's on Titan?
Yes, it's gonna fly on Titan. It's got 4 rotors, and it should be able to get around quite well. It has enough atmosphere to do that. Engineering mostly, as far as experiments on it, that's over in the science side. It's all hand in glove. Scientists and engineers work together on these things. There's some interesting stories over the years about communications between scientists and engineers that I've personally witnessed, which is kind of interesting. It's always funny. There's always a little banter going about, in that area. I remember I went to JPL several years ago, and there's a bunch of guys from Marshall, and Marshall is mostly known as an engineering center. We do science, we have science, but it's primarily known in the agency as an engineering center. And so we walk into a conference room, and they've got the first chart up welcoming all the engineers from Marshall. The next chart says engineers do the work of man. And then the very next chart was, but scientists do the work of God. And I'm like, oh, here we go. It's going to be, this is the way this meeting is going to work. But it's all fun. It's all just banter between people, and they have to work together, and they do. Mm-hmm. Yeah, more than likely. I haven't seen. It's a fairly new concept for us so far. It's in fairly early stages of planning. If we do it like we did, we do have one on Mars right now that landed with our last lander. But I mean, the atmosphere is thin enough on Mars that we can't really move around a lot with it. We've been able to lift it and sit it back down, and it's done that a few times. And so, oh yeah. Yeah. Mm-hmm. Yep. The Dragonfly will be able to go, hopefully, where we plan for it to go. We'll identify interesting places for it to land and study with the instruments that we're able to put on it.
I think landing near one of those lakes, like or or Kraken would be really interesting.
Oh yeah.
There might be life there too.
Mm-hmm. Yep, and hopefully we get enough data. We may not be able to send enough instruments on something like a drone to actually give us that information, but we can get enough information to know that we want to go back with something bigger. Maybe a lander, maybe a roller. A rover, something that can carry more hardware that we can do more studies with. Mm-hmm. Oh, wouldn't that be cool? Yeah. Anybody else? Nobody want to know how an astronaut goes to the bathroom or anything? Uh-huh. Yes, it's an official graphic right now, so yeah. So there'll be some interesting things come out of that. Oh yeah. Yeah, most of the time they are, and then they'll go through several different iterations of them. There'd be different teams that work on it in different areas that come up with their own patches and stuff. OSIRIS-REX had several different ones. I remember those. But anyway, if that's all you guys have got, I really appreciate you being here. How many of you are going to get to see the launch? Okay, great. Awesome. That's good. Do you know where you're going to watch from? Your house? Well, how nice. Are you going to watch it from campus, or are you going to watch it from the? All right. Wait, I got a question. I got a question for you guys. Lompoc, Lompoc. Poke. Uh, I understand that. I come from the Valley of the Sick Head. So, yeah. Okay, so it's poke because I hear it both ways, and my phone loves to say pock. And, okay, Lompoc. Better. Now I know. All right, so I'll be at Hawk's Nest, right? And I know that there's a lot of students, and several of us going with the students to the Lompoc campus. There's a place to watch from there. So that'll be good. And like I said, we'll have staff there to answer questions and everything as well. So again, oh, yes, sir. What happens if what? I'm sorry? If it can't take off tomorrow night, I think, we've got one more night?
Yeah, so they do different launch. So it's just a 1 minute window tonight. So if it doesn't launch during that 1 minute, then it'll go to the next night. And then the window stays open for, I think, 2 nights. So
But it's going to launch tonight. Yeah, it's going to launch tonight. By the way, this is Stephanie. Stephanie Henry works with me. She's worked with me for longer than she would like me to tell. And we travel all over the place, and we talk to people mostly. But yes. A lot of it. I mean, the windows can be because of several different variables. I mean, it could be a timing as to where the Earth is at a particular moment. It could be timing as to where something else is. Now, this particular mission, a lot of our windows, some of our windows, are determined by where other planetary bodies are because we use gravity assist on many things. This one is not a gravity assist mission. We're using the thruster for the whole thing, for the speed, for everything. We're not going to loop around, Mars or the sun or anything like that. So I'm not really sure necessarily what's driving this particular window, at least the 1 minute window that we have. Sir, you might know the answer.
is this going up on an Atlas 5 rocket?
Not this one. This is going up on a SpaceX Falcon 9.
Will we be able to see the stage come back?
The stage will land. It won't just splash down and be recovered. It's not at Vandenberg. It will land on a floating platform. Yeah, and oddly enough, I found this out last night. The actual name of that floating platform is "Yes, I Still Love You." That's the name of the ship or the platform. So I thought that was kind of interesting. I don't know how that one slipped past me, but it did. So anyway, again, thanks everybody for showing up. Go Dart, and let's get this thing going.